class, and welcome to Unit 6, which is solving polynomial functions. Before we get into solving the polynomial functions, let's just take a minute or two today in our lesson to practice some algebra skills that we should learn from polynomial expressions. So today's task is to use your knowledge of exponent laws, distributive property, and factoring to simplify the expressions. So for question 1, it says the length of a rectangle is 3x plus 4, and the width is 2x minus 6. Determine an expression for the area of the rectangle. Well, first of all, I'm just going to quickly draw a rectangle because visualizing it helps me. So I'm going to go 3x plus 4 to make sure I show it a rectangle. There we go. And the width is 2x minus 6. In the past, ladies and gentlemen, we would just say area equals length times width. But notice in the length and in the width, ladies and gentlemen, we have an x value. So I'm going to say function notation is area with reference to x equals the length, which is 3x plus 4, times the width, which is 2x minus 6. Now, when we are asked to determine an expression, we don't want to leave it in factored form. We always want to expand and keep it in standard form. So we're going to use FOIL, which is first, outside, inside, and last. So doing that, you're going to have 6x squared minus 18x plus 8x minus 24. And then don't forget to collect like terms, ladies and gentlemen. So it's going to be 6x squared minus 10x minus 24. And because this is a word problem, therefore, area expression is, and you would write it out, 6x squared minus 10x minus 24. Great. Let's take a look at number 2, which is called expanding. So we're going to use the distributive law, which means everything outside of a bracket gets multiplied inside when there's a multiplication. Okay? So let me just say that again. A term outside a bracket gets multiplied by every term inside the brackets. Okay? So I tend to break it down into its sign, then the coefficients, and then the variables and their exponents. So first of all, positive times a positive is a positive. 1 times 4 is 4. I go in order, alphabetical order for my exponents. So I go x to the power of 8 because you've got to add those exponents, and y squared. Looking at our second term, ladies and gentlemen, positive times a negative is a negative. 1 times 3 is 3. And then we've got x to the power of 7 and y to the power of 2. And our last term is going to be 1 times 7, which is plus 7. And then we go x to power of 3. And then we go y also to the power of 3. Okay? Any questions of that? You should note that, ladies and gentlemen, you can't do anything further because these are not like terms. Although they all contain x's and y's, they are different. They're unlike terms. Okay. Now B is a little bit more challenging. Okay, and you can do this in 2 parts, and that's what I'm going to do. I'm going to break this up and do a distributive law here, and then at the same time, realizing that these are multiplications, I'm going to do a FOIL here. So first, outside, inside, last, and all the arrows represent a multiplication. So starting off, I'm going to end up with 3x squared minus 12x. Okay. I'm going to still multiply that by the FOIL that I'm going to do here, which is x squared minus x plus 5x minus 5. Okay. And then, ladies and gentlemen, before we can multiply through, we have to collect like terms right here because BEDMAS tells us to do that. So I'm going to write my first binomial as is. My second term here is going to become x squared plus 4x minus 5. Now I can take my binomial and multiply it by every term in my trinomial. So it's kind of like FOIL, but you're going to have, instead of 4 arrows, you're going to have 6 arrows. All right. So let's take a look at doing that. So it's going to be 3x to the power of 4 plus 12x cubed minus 15x squared. So that's the first set of arrows. Now I'm going to do the second set of arrows using my second term, negative 12x here. So it's going to be negative 12x to the power of 3 minus 48x squared and minus, oh, sorry, a negative times a negative becomes a positive, and that's 60x. All right, then we look to collect like terms, always putting the highest power first, ladies and gentlemen, because we always put the highest degree first. We've got 3x to the fourth. There's no other x to the fourth. Okay, then we look at our x cubes. What you should notice is 12x cubed minus 12x cubed, they cancel. Okay, and I apologize. Let's back up here. I have no idea what I wrote here. This does not look good. So let's see, what should that have been? Oh, 48x squared. Sorry, I don't know why I wrote an xx there. So I know I made an error there. All right, so let's take a look at the x squareds here. So we've got negative 48 and another negative 15. That's going to be 63x squared negative. Okay, so it's going to be negative 63x squared and plus 60x. I'm just going to fix this. Just going to rewrite this, guys, so it doesn't look so bad. Okay, so 48x squared. All right, and ladies and gentlemen, notice in this trinomial that we end up with, they are not like terms, so you can't do anything else. All right, I believe this is our last question. Yep, last question today. The area of a rectangle is given by this dimension, which is 14x squared plus x minus 3, where the width is 2x plus 1. Determine the expression for the length. So what we remember is area equals length times width. Okay, the area is given in this case, so it's 14x squared plus x minus 3 equals the length, what we need to find, times the width, which is 2x plus 1. So just remember, folks, to go from area, which is in standard form, to length times width, which is factored form, we need to do what? We need to factor. So we're going to take an example of the area and factor it to get our two terms. So what we need to do is to factor. So I'm just going to rewrite my area. Okay. And what we're going to do, ladies and gentlemen, is we're going to take a look at what method of factoring shall we use. Well, first of all, we always look for common factoring. Can we common factor here? No. So we're going to look at decomposition. So if you forget how to do that, pay attention here. I'll give you some steps. So this is decomposition. Why is it decomposition? Because it's a trinomial where a does not equal 1. Setting up your margin on the side, depending on what teacher you've had in the past, I always do product. So product equals a times c. So my product is going to be negative 3 times 14, which is negative 42. And my sum equals 1. Okay? Be aware of the signs here, ladies and gentlemen. For a product to be negative, that means we have to have at least one negative. And we need the sum. That is going to be, we need a sum that's going to be 1. Okay, so we need to think of all of our factors. And remember, ladies and gentlemen, if the sum is 1, that means our biggest number must be 1. So I'm going to make negative 1 times 42, negative 2 times 22, 3 goes in, hold on a second, 14 times, so negative 3 times 14, 4 doesn't go in, 5 doesn't go in, the 6 go in. Yep, so it's negative 6 times 7. Okay? Which one of those, because all of those suit that classification, but which one of these 4 will, when you add them up, have a sum of 1? And that would be the last factor. And remember decomposition, we take it a little different. We split the middle term. So you rewrite the first term as is, so 14x squared. The middle term we split, so it's going to be minus 6x plus 7x minus 3. Notice, ladies and gentlemen, when I split the middle term, I've kept it balanced, because if you take 6 subtract 7, 6x subtract, or sorry, 7x subtract 6x, you still have 1x. So I've left it the same. Then what we do is called factor by grouping. So we look at the first two and say, hey, what's common? And you should say a 2x. What's left over? You should have 7x minus 3. Looking at here, there's nothing else to factor out, so it's just going to be a plus 1. So we're going to have 7x minus 3. Notice now that there's a common binomial. So the common binomial goes out front. And then your leftover is 2x plus 1. Now we can relate this back to the problem up here. We already know that this factor is our width, right? And so what does that mean? That means that this expression here has to be our length. So then we answer the question. So therefore, the length is, in brackets, 7x minus 3. All right, and you don't necessarily need the brackets in there. I always like to put it in because it's a complete term. All right, so here's your intro lesson to Unit 6. We're solving polynomial functions, but that's just a practice of factoring and expanding. Just remember, guys, that when you factor, you work one way. So you take the product, and you break it down into its parts. Okay? But if you take the parts and create the product, you're doing the opposite, which is called expand. Okay? And you use one method to check the other. So use factoring to check expanding. And likewise, let me make some more room here. You're going to use expanding to check factoring. All right, great. So just remember they're opposite operations when you factor and when you expand. All right, here's your homework, folks. Page 112 to 113. 1A, 2, 6A, 8, 9, 10, 12, 18. If you want to print off the attached formula sheet, go ahead and do so. Or see the Roman numerals, which is right at the beginning of the book, guys. Roman numeral 7 and Roman numeral 8, which looks like this. Okay, right here, that's 7 and that's 8 in your textbook. Okay, I'm sure it's at the front. If not, check at the back. I just don't have one handy with me right now. Anyway, have a great day, guys. And you know what I'm going to say. So come see me if you need any help. Goodbye.